Alright guys, welcome back. We're going to be solving another question from the chapter 4 of Engineering Mechanics by Meriam, and we have this outrigger extension for traveling crane that is designed for loading ships, and we know the beam AB has a mass of 8 megagram. So we know mega is 10 to the 6th. So this can be written as 10 to the 3 kilogram. So whatever value that we have for this, if we just multiply that by 1,000, it's going to be in kilogram. So the beam AB has a mass of 8 megagram and the mass center is at its mid-length. So we know the length of AB is 10 meters, so the mass length would be exactly, the mass center would be exactly at the center of this AB. And also we have information about boom BC that has a mass of 2 megagram with mass center 5 meter away from point C. So if we just consider this center mass, this is going to be also 5 meter. And we have 2000 kilogram carriage, or if we just want to write all the dimensions, this is going to be 2 megagram just to keep all the units in the same format. So the mass of the carriage is 2 megagram or 2,000 kilogram, and we know it's symmetrical about its load line. So nothing is going to move that center of mass that we have because it's symmetrical, would be exactly at the center. And we need to calculate the magnitude of the force supported by the hinge at point A. So we are looking for the reactions at point A. When the load M, or this box that we have in here, is also 20 megagram. So we are in equilibrium, 3 equations, sum of all forces in X equals 0, same for the Y. And we're going to have one moment equation about any points that we want. But before that, we need to dismantle the system. And what we're going to do is that we're going to start with the top part, or the member AB. And we're going to try to show all the forces that we have. And after that, we're going to move to boom BC and see what we can find from that member. So at point A, we have a hinge or a pin, which means we have two components, AX, AY. And we can just show our X and Y axis here. So we're going to have the weight of the beam, which from the question we know is 8 megagrams. So we know weight is equal to mass times acceleration of gravity. And our G in here would be 9.81 meter per square second. We need to put the mass in kilogram to get the Newton's unit. But since our mass is based on 1,000 of kilogram, our unit is going to be kilonewtons. So that's one thing that we need to keep in mind. So here the mass was 8, so 8 times 9.81, this is going to give us kilonewton. Also, we have the weight of both carriage and the mass m, which is going to be 2 plus 20. So we have this 2 megagram that we discussed for the carriage. So 2 plus, just going to show it a little bit. Maybe here, so 2 plus 20 times our G. And we have another hinge at B. We can call two components for that one to BX, BY. And that's pretty much everything that we have for this member AB. So we can start with our moment equation. We can do either about point A or point B, really doesn't matter. So let's just go with A. So we're gonna have the moment of the mass of the beam, counterclockwise moment, so positive 8 times 9.81. The distance we know it's 5, because the question told us that it would be mid-length. So times 5, we're gonna have the moment of the carriage and the box. That's going to be 22 times 9.81. Again, same direction. It's going to be a counterclockwise moment, so positive. And that distance, we know it's 4 meters to the left. So the distance from D to A is going to be 6. And the last one is going to be the moment of By. This one's a clockwise moment, so negative times, it's basically the length of the beam, which is 10, equals 0. And from here, we can find By. So this is going to be our ratio. So 8 times 9.81 times 5 plus 22 times 9.81 times 6 times 6. And in the denominator, we're going to have 10. This is going to give us 168.74 By, and as we mentioned, it's going to be kilonewtons. We didn't get a negative sign, so that was the correct direction for By. So now that we have this, we can also find Ay from this member. So if you just do sum of all forces about y equals 0, basically we have all these forces that we had in the previous step, except we're going to have Ay too. So Ay plus By 168.7 minus those two forces, we can just factor 9.81. So let's just write it down. 8 times 9.81 minus 22 times 9.81 equals 0. And Ay in here is going to be, so 30 times 9.81 is 1.168.7, and the Ay is going to be 125.6 kilonewtons. So we found one of the reactions. Again, no negative sign. This is also a correct reaction, but we need to figure out the AX. And if we do our FX equation, we have two unknowns, AX and BX, so we cannot figure that force out, which means we need to move on to another member, and our second member would be the boom. So again, we have same story for C, CX, CY, but we're not interested in that. We're gonna have the weight of the beam, which from the question, we know the weight of the boom is 2 megagrams, so 2 times 9.81. And we figured By. This time you have to keep in mind that the B1 is going to be in this direction, because based on the Newton's law, this has to be in the opposite of the previous member. So we'll be downward, and also we can consider Bx in this direction here, see what we get. Again, I try to color code what I'm doing in here, free body diagram and the equation. So now we are only discussing the free body diagram of member. But that's pretty much all the forces that we have for this member. What we are interested in here is Bx, because that way we can get back to our previous free body diagram and find Ax based on Bx. So we're going to start with our moment equation about point C. We're going to get rid of all the unknowns at C, and we should be able to find Bx. We already know By because we found it from the previous step. So we should be able to find the Bx. So let's start with the Bx. First of all, the moment is going to be a clockwise moment, so negative times the distance would be basically the 7 meter that we have in here. We're going to have the moment of By. This one's counterclockwise. Again, you need to watch for the direction of By based on previous steps. So keep in mind that that's very important in here, because it's going to mess up our equation if we go with the other direction. And now we're going to need this base of this right triangle that I'm highlighting in yellow. So we need the base of this right triangle, and that's not that hard to find if you just call this angle alpha. Tangent of alpha is, so alpha would be tangent inverse of the opposite, which is 7 divided by adjacent. Adjacent would be 10. So just have to, adjacent would be 10 plus this little distance, 1.5, so it would be actually 11.5. So we can figure out the alpha pretty easy in here. Tangent inverse of 7 divided by 11.5, that's going to be 31.3 degrees. All right, now that we have that, and we're going to have the moment of the weight, which is in here. This one's also counterclockwise, so the force was 2 times 9.81, and the distance, we know now we have another right triangle, which is this right triangle, and that's where we need the angle alpha. We know the hypotenuse is 5, so we are interested in the adjacent, so it's going to be 5 cosine of alpha, or 5 cosine of 31.3. All right, this should give us the px. So let's go with our ratio again. So 2 times 9.81 times 5 times 5 cosine of 31.3 plus 168.7 times 11.5. All right, so our px is going to be 289.1, again, kilonewtons, and we did not get any negative sign. So for this member, the direction for, I don't know why I changed color in here. So this was the direction for the red free body diagram. So this is the direction for red. Actually, I should have written all of this in red. And it really doesn't matter because at the end, we figured that bx on the other member is going to be in the left. So ax is in the correct direction. If we just do sum of all forces in x from the free body diagram of member A, B, so we're going to have ax minus bx equals 0. So basically our ax is also 289.1 kilonewton. And if we want to find the final answer, is square root of ax squared plus ay squared. So let's just write down the final answer in here. Square root of 289.1 squared plus 125.6 squared. And this is going to give us 315.2 kilonewtons, and the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.